So I'm here to talk to you about some work that the INCOSE academic community have been doing, looking at systems engineering knowledge, systems knowledge, and where it fits into education. So this is our goal, and I'm going to give you some background and justification for this goal. I'm going to give you a brief overview of some of the things we've been doing, and then I'm going to finish off by talking about where we're going, plans for this year and next year. So the Academic Council holds a number of what we call academic forums. They used to be within the International Symposium, and we do still things at the International Symposium. International Symposium was good. But more and more we're doing things outside of those events at universities to bring people together to talk about academic-related things that might be of interest to the INCOSE community. And from those academic forum meetings, one of our goals is represented here. And so we're looking to improve the general education of all engineers by increasing the use of relevant systems engineering knowledge, skills and attitudes, and I may use the abbreviation KSA elsewhere in the presentation, in the university education of all engineers. This is not just systems engineers. Why are we doing that? What are we trying to do to make that happen? And how are we going to implement these changes over the next few years is the theme of my talk this morning. So why? Well, these, as far as I'm aware, is the latest version of the INCOSE vision and the INCOSE mission. In fact, I know this is fairly relevant because I took it off of a Facebook post that Alan Harding was presenting on Friday. It's becoming more and more outward looking. So if you trace the history of the INCOSE vision and the goals over the last 2 or 3 years, it's less and less about promoting systems engineering, and it's more and more about reaching out and adding value in society. And so we were looking for an academic goal that plays into that broader agenda of doing systems and systems-related things that have value to society as a whole. And that very much plays into the Vision 2025. It's a little small to read there, but it talks specifically about broadening the scope of systems engineering and relating it to other disciplines. It talks about education, and it talks about professional practice, and we want to try and enhance those things. Based on that, one of the first things we did, I think 3 years ago now, maybe even 4 years ago, was to engage with some of our industrial representatives to talk to the CAB, and to try and get a view of where where engineering practice was going and where engineering education was going. So this slide is quite wordy. The top part says that from the initial outreach that we've done, it seems that engineering practice in the 21st century will become more focused on teams of people with a variety of skills working together towards stakeholder value. So it's less and less about practicing the engineering you learned at university and more about contributing as part of a team to providing real value to our stakeholder community. And that requires engineering graduates who have a core specialist skill and knowledge. We still need those educated professional engineers in a range of disciplines, and a set of shared system skills which bind them together and allow them to focus on the larger problem and to deal with the kind of complexity and emergence which we all in this community will be very happy with, and the ability to work as part of a team to deliver that. And we think that systems engineering and the systems engineering body of knowledge offers some knowledge, skills and attitudes into that community which could be very valuable. Now this is our first pass of engaging with industry to ask this question, and part of our ongoing work is to continue this conversation to figure out if we got this right and to figure out what it means and how we can deliver it and what some of the obstacles to delivering it are. And I'll get to those things at the end of my talk. There is a broad range of things we could do related to education. One of the things we've been doing as part of this work is working with the American Society of Engineering Educators, which is one of the international societies that looks at engineering education as a topic. And they have what they call their pathway to the global engineer. What will it mean in 10, 15, 20 years' time to be a qualified engineer working in a global market? And one of the things that some of our team did was to put a particular system spin on that. So if you like, what kinds of things should we be promoting in young children to set them on the path to thinking in a systems way? What kind of things should we develop in terms of their approaches, their perspective, their working with other people, their skills to develop them in school? In particular, how should we develop them in their teenage years, in their high school education, in their young adult years, which is generally where you get your undergraduate education, and in their early adult years, where many people get master's education and begin their professional practice, and then passing them on into becoming lifelong learners and professionals. And I've highlighted the two middle bits of that, because that is where most people get their university education. So we've decided, not that it's the only thing that we could do, but that it has significant value to the community, and also from an INCOSE point of view, helps to raise the profile of INCOSE as an organisation involved in academic activities. INCOSE hasn't really been a big player in ASEE, it hasn't really been a big player in ABET and the other international accrediting organisations. So we're as interested in raising our profile as an organisation in that community as we are in adding the value, and we think we can help. So there's lots of things we could do. There's STEM activities, there are other communities, there's research and professional development, but this piece of work is focusing on the university education of all engineers as being a good place to start and a place from which we can grow and expand our thinking. So what systems engineering knowledge, skills and attitudes do engineering students need was our second question, or our concurrent first question, because we're systems engineers, and if we're not doing at least 5 things at once, we're not really trying. So what are we trying to give people? In order to answer that, we held some workshops. Our intention was, the things along the left-hand side there is what we know. So we have our knowledge, our books, our ideas, our understanding of systems and systems engineering and its relationship to other disciplines. We have things like the systems engineering body of knowledge, which is an attempt by this community to quantify the broad scope of knowledge important to systems engineers and the practice of systems engineering, and by its nature goes into other disciplines and into professional practice. And we have the knowledge and ideas in the heads of the people in our community. Many people in INCOSE are already providing systems engineering education to general engineers. Many of our programs provide courses into engineering programs more widely. So we already have some of the answers to this, and we're looking to build on those. We held some workshops, and what we wanted to produce was more knowledge. Are we on the right track? Are we asking the right questions? If not, what do we do about it? The beginning of some material, because again, from a systems lifecycle point of view, we want to start solving this problem and then see where that takes us in terms of better understanding it and further solving it. Some pedagogy, some theory and underlying ideas that we can play into the educational community, and community, a group of people interested in this topic. And these workshops, although they were organised by INCOSE, were not just for INCOSE members. So we had significant contribution from the ASEE, from the IEEE. We, in November, went over to India and did a workshop as part of the APCOSEC conference, where we had significant contribution from people in the Asia-Oceanic region, and we'll continue that outreach. So this is not just INCOSE, in fact, very much not just INCOSE. That's part of our agenda here. We will be presenting some of this work at the ASEE conference in June. I've already presented at the ABET conference, and we'll be continuing that outreach. So what knowledge do they need? And I'm going to skip through some of these bits because I want to give you a flavour of this and then leave myself enough time to tell you about our plans and direction and maybe even take a couple of questions. So we started from a number of things, but one of the things we started from was the systems engineering body of knowledge, because that's not really a start. We've already done, as a community, significant work on this. And it already has a strong educational flavour, because as anybody who's heard me give one of my bookcase talks will know, the body of knowledge, one of its primary goals was to support master's education for systems engineers. So what's the subset of this, if subset is the right word, that we might encourage to be included in the education of all engineers? Well, in our early workshops, we've proposed some thoughts on that. So we've identified some broad areas, some of the fundamental system ideas, and you're going to hear a talk following me on where we're going with how we bring the broad range and scope of systems thinking down to something that makes sense for engineering, and some of the practical systems thinking, how we use systems thinking to shape and frame problems, to drive what we're doing in a problem-solving kind of way. Clearly, the relationship between systems engineering and system design is a key thing, but also those life cycle issues. How do we organize ourselves? How do we deal with risk? How do we solve problems together? And we think that those things are already covered by many engineering degrees, but we think we can help them cover them in a way which follows some of the principles and practices of systems engineering and broaden that scope to a wider community of people. And from that, and this very much is draft, we wanted something to get started on. So from, I think, 2 or 3 workshops, which means, I don't know, 50, 60, 100 people have contributed to this, we've identified, and I think there are about 30 things there, particularly if you split out the abilities, probably closer to 40 or 50. So a number of specific topics identified from the body of knowledge, which we think are already covered by engineering education, or really should be enhanced and improved and have that systems engineering perspective on them. And then, in order to make some progress, we arbitrarily picked our top 10 of those. And by that I mean we had a number of votes and we put post-it notes on whiteboards and we clustered things together until we ended up with the answer that I wanted. And then that became if you've ever been to one of my workshops, you'll know what I mean. That became our starting point for engaging with the wider community. And we've taken that list and we've discussed it with engineering educators and engineering faculty. And there's been, and there's a paper here written by some of the people in the team, Alice Squires, Fred Luft, Shams Farani, presented at ASEE, where we presented the difference between what the systems engineering community thought was the most important thing on that list and what the engineering community thought. And partly that's because they thought some of those things they were already teaching and they didn't need our help, and partly it's because they didn't have the same perspective on some of those things as we did. So we think there's a dialogue to continue having there, and we'll be doing that at the next ASEE conference and beyond. This is a starting point, it's not an end point. I think that this year we might start to describe something which might more formally look like a curriculum for systems engineering knowledge in engineering degrees. This is not that, this is a beginning of that conversation, but it's already given us, I think, some interesting insights. Along with that, we looked at why is this difficult, and these are some of the things that the engineering community said would be, engineering education community said would be difficult. We've got to get faculty up to speed before we can educate students. There is a history of covering some of these topics in some universities which has left a bit of a legacy in terms of it not really not being done in a way which was relevant to them, being seen as preachy, being seen as in the wrong place and too abstract or too simple and obvious and common sense. And we can't seem to hit that sweet spot between this is too complex and this is too easy. So there is some history to overcome, and that's part of our job. If you try to give students the systems engineering body of knowledge in their first year, they won't understand it and they won't want it. So you have to build up to it. And a number of other things, and in particular, some practical issues. Curriculum's already full. Why should we put your stuff in? What do we have to take out? So there are some real practical challenges, and we've been trying to deal with those alongside the theoretical challenges in order to move this thing forward in an iterative way. This is another way of expressing that. There are some pros and cons of trying to do this and engaging the community, and we're trying to find the community of interest in this. Who are the engineering educators who want to do this and are struggling to do it and need our help? And if we can get them, then the next task is to find those people who don't know they want to do it, but when they do know, will get it. And that will then leave us with those people who, I'm getting a bit Rumsfeld here, don't know that they don't know they want to do it, and when they do know, won't want to do it. And we'll probably just have to wait for them to retire, and then we can move the agenda forward. So we're trying to grow this within the community in a bottom-up way, and we're having some success with that. And at some point, we'll want to flip that round and start to push some of these things down with some of our senior colleagues in engineering. We've already identified some deans of engineering who have a systems engineering background who we can begin to use to help us push this thing top down as well. And that's going to be an interesting journey. I went to India in November. I'm not bragging, it's just part of the presentation. I had a very nice curry. We had our first meeting of these in the UK, which I hosted, but that was really feeling our way. We had a number in various universities in North America where we framed a lot of these things, which included some international contribution. But we want to get out to the other parts of INCOSE and the other parts of the international community and make sure we're doing the right things and also learn from those other communities. The way that education is done in Asia, Oceania, the way that it's done in some areas of Europe is different to the way it's done in North America and to some extent in the UK. And that difference, in some ways, promotes systems values that we could learn from, and in other ways doesn't, and actually gets in the way of systems values. So we want to learn from those things. So the workshop in India was about sharing what we've done and getting their feedback on it. It's about getting them to identify what their regional challenges are, which are the same but different, a bit more resource issues, in some ways a bit less crowded curriculum, because they want to do these things, they just have to figure out how to do them. And also to get them to tell us their ideas that we can learn from. We had a very interesting session. I've put this in, I could have redrawn it so it was easier to read, though I don't think it's bad. This was produced by some of the engineering faculty and engineering students at the university that we were visiting. And this is effectively a spiral approach to bringing systems knowledge into engineering education. So in their first year, help them understand why problems are difficult and confusing. In their second and third years, give them examples which are increasingly, they start off being about thinking about systems, and then they move into how you do engineering and multidisciplinary. In their final year project, give them systems engineering as a framework for doing it, and then introduce them to formal systems engineering and INCOSE right at the end, when they've got a chance of getting it. And I think there's some really interesting ideas in this framework of a way of building this knowledge up. So I'm quite excited about taking this forward. And in fact, one of the Indian professors who came along to give a keynote speech had shaped some very similar ideas, and we talked about those during the day. The interesting thing was that there were a number of first-year engineering students who happened to be the students of the engineering course of the host university, and they'd done 1 or 2 industrial placements, and they'd come back saying, we want to know about multidisciplinary engineering, we want to know about life cycle, we want to know about problem solving, because that's what people are talking about in our industrial placements. So first year engineering students were definitely getting it. Some interesting stuff there. And that's the kind of thing that we do at our academic forum meetings. So if you are an academic interested in this topic, try to get along to one of these meetings or to one of the events we're holding at some of the international conferences this year. As I say, we're doing something at ASEE. I'm hoping to do something at the IEEE Systems Conference. I'm hoping to do something at the INCOSE conference in Australia and maybe in somewhere in Europe towards the end of this year to try and help us develop these things. That leaves me with 10 minutes to talk about how we take these ideas and move them forward. And really, when we started this project, in the spirit of that we were already solving it and had to bring those ideas together, we wanted to really shape and understand what we were doing, and we wanted to have a vision. We've been taking this approach of looking for quick wins, if you like, looking for things we can already do, beginning to leverage and work with the community, as well as having a vision of where we were going and how we might get there in a broader, more strategic sense. We've been lucky that, I suppose lucky is however hard you work, you get luckier and luckier. We've had a number of people in INCOSE, Phil Brown, who I can see, and a couple of other people who have been working closely with ABET, the accrediting organization for all engineering education in the US. They were looking at their top-level criteria for what makes an engineering degree and reviewing them as a community, and partly out of this work, the INCOSE community have offered some amendments to those criteria that include some systems language. They're very specifically shaped not to say, do systems engineering or follow our body of knowledge or follow our standards, but they include ideas of systems, they include ideas of exploring broader problems and taking a through life approach and those kind of things. So they've been included in the draft criteria as a way of getting to the whole community and influencing things top down. And I think we've just about got to the point in this work where we've got enough momentum and enough really good ideas that we can start tackling this more strategically. We can start going to universities, going to professional societies, and trying to promote this as a top-down strategic approach, as well as continuing to learn and build bottom-up and to improve what we're doing. So that basically is the agenda for this year and next year, and we'll see how that goes. The last workshop we had in the US, which was back in May, June, I guess, we summarized that workshop by listing what will the world look like in 12 months if we're successful in this? What sort of things will start to happen was the language of this. So initial systems engineering examples of existing programs that are already doing it will have been brought together and shared with faculty. We'll have got some feedback with industry and the community to get confidence that the things in number one are good and add value. We'll have found a way to more systematically collect and validate those things as a more joined up rational resource going forward. I won't read all of these, but we'll have got a part of the challenge of this and part of the history of this was that the language of explaining systems engineering to other people has to be thought about carefully. If you go and tell them that, we know you have problems with this and we can solve it for you, if you speak to them in abstract ways, if you don't understand the value of what you're trying to do because it's so ingrained in your brain that it's just obvious to you, you won't be able to sell these ideas to people. So forming these ideas in a language which makes sense to deans of engineering, to engineering students, to employers of engineers, not just systems engineers, is one of the critical things and one of the things that we've been working on and will continue to work on. Go back to the community, identify our stakeholders, do a more rigorous analysis of the need and the drivers, and get a more joined up view of what should be pushing us forwards next, and begin to initiate some more formal research. There are things I'd like to know the answer to in a more formal, structured way that a proper research project would be able to help us with. And I think we're in a position to look for some of those research activities and have an input to them and get their output to feed back into what we're doing. And publicise it more widely and share it with people, which is why I'm here. So, because we're systems engineers, if we've got a list of things, we've got to summarise them. So those 11 things end up as 4 big areas: clarifying the message, engaging with the stakeholders, having examples and prototypes and delivering value immediately, scoping and conducting research, and sharing it, which is what I've got here. So that basically shapes our agenda for the next 12 months, certainly, and we'll be talking in our academic council meeting on Monday about how we might take the work that's been done here and maybe package it into a more formally defined INCOSE initiative of some kind and start to drive it forward with INCOSE's weight behind it in some way. And because all of this iterative bottom-up stuff is great, but you need to have some vision of where you're going, I think this is the last thing I want to show you, is what might the future look like? I probably shouldn't say this, but I have this unfortunate freak of honesty that I just can't seem to get rid of. Those of you in the team will notice that this slide used to say 2020 goals, and now it says 2025. I know you'd seen it, Larry, thank you. But I'm trying to align that with the vision 2025, that's my excuse. And maybe, we'll have achieved some of this by then. But what will success look like? And success might look like these things. That all national and international accreditors, I should say international now, we'll change it, have these things in their engineering criteria. That we have schools that recognise it, that we have faculties that use it, that we have a shared resource through organisations like the ASEE who are promoting it, that it sits alongside the INCOSE CBOC body of knowledge as one of the things we promote to the rest of the world as the value of the systems engineering community. That students and employers want to do it. That when you're choosing an engineering degree, you're looking for one with some systems in it. And when employers are recruiting people, they're looking for recruits with some systems engineering in their engineering degree. And that the results of this have been shared and improved, and it becomes an ongoing activity. So that's all I want to say. There's 5 minutes if anybody has any questions.